All right, today we are going to be reviewing some stuff from last time, 1.1, 1.2 vocabulary, focusing on naming and identifying things in our diagram and different types of geometry. So starting here with our first thing, we are given a line and we have three possible ways to name this. Now remember, a line, our symbol for line looks like a line. We have a line with arrows on both sides representing our symbol for line, and one way that I can name this line is by 2 points that are on the line, A, B. That's one way. Now for a line, the order of the points doesn't matter, so I could also call this line BA with that same symbol above it. And then the third way that I can name this line is because I have that script cursive L above it, I can name it with the words line and then that script L or M or whatever letter is above it. You can call it these three ways. Now what about our angle? The four possible ways to name an angle, which we reviewed the day we did vocabulary, when we used our three letters with the vertex always being in the middle. So we could call this angle CED with our angle symbol. That's one way. Another way would be to do it backwards, DEC. So same thing. A third way would be to name it with that number that's at the vertex. If there's a number inside your vertex that refers to the measure, you can call it angle and then that number, in this case, angle 7. And then the fourth way that we can name this one is just by the vertex. We can call this angle E, but we can only do that because this angle does not have any other angles that share a vertex. If I had an angle like this, or let's call this angle G, H, J, and K. I cannot refer to any of these angles by just angle G because I have angle HGJ, I have angle JGK, and angle HGK. There are three different angles that have vertex G, so I can't just call it G. But on this one, I don't share this vertex with any other angles, so if I call it angle E, you absolutely know which angle I'm talking about. The reason we name these parts and pieces of geometry is so in a diagram you know exactly what we're referring to. Okay, let's look at the next one. Ray XY. Can this be called ray XY? Let's look at what we have in our diagram here. We start at Y and going off to infinity through X. So remember a ray, that's the line with an arrow pointing one direction. So if I were to talk about ray XY, that ray would start at X and go off to infinity through Y, meaning it's going to be pointing the opposite direction from what's drawn here. So no, you cannot name rays any other way. You have to name them first with the starting point and then with another point along the ray. All right, name the sides of triangle RST. So you could do this without a picture because you know the points, but let's draw it. Angle RST, triangle RST. You could put these points anywhere else on the triangle. It truly does not matter. So what are the sides? The sides of our triangle are going to be segments, which means I'm going to have just a line above them with no arrows because it's a line segment. So our three sides, we've got RS, we've got ST, and we've got TR. Now, those three segments, I could also name the other way around. I could call this SR, TS, or RT. For segments, you're naming it with the endpoints, but the order does not matter. They're the same segment either way. Same with lines. The order doesn't matter. All right, vertex of angle TOS. You should also be able to do that without drawing it, but if I've got angle TOS, the vertex is at point O. And then another way I could name this angle would be SOT or just angle O. All right, last one for this page. I've got right angles at each corner, which means they equal 90 degrees. So if TPO is 60 degrees, what is the measure of angle RPO? So this angle here. Well, if the total for these two angles forms a right angle, meaning it's 90 degrees, if I subtract that 60 from 90, that leaves me with 30 left over. So that angle is 30 degrees. If angle PTO is 70 degrees, what is the measure of angle STO? So this angle here. Well, again, that one also forms a right angle, meaning those two add up to 90. So if I subtract the 70, that leaves me with 20 left over. Okay, then angle TOP. This angle here is 50 degrees. What is the measure of angle POR, this angle here? Well, I know that TOR forms a straight angle, which means it adds up to 180 degrees. So if I subtract 50 from 180, that leaves me with 130 degrees. And then angle TSP, that is this angle here. What are other possible ways we can name that angle? Well, we can just go ahead and name it backwards, angle PST. I cannot just name it angle S because notice I've got this angle, angle RSP, and angle TSR that all have that same vertex. But O is also a point on this ray SP, so I could name it angle TSO or angle OST as well, and you know exactly which angle I am referring to. All right, I'm going to move on now to the union and intersection problems, and I'm going to put it in a dry erase sleeve so that I can erase and redraw over my diagram. So I'm going to do that and turn off the glare. There we go. So intersection and union. We looked at these words in our vocab, but now we're going to look at the different types of problems we can use. So remember, union, our symbol is that capital U, and this is all the elements in two or more sets. And then an intersection, which looks like an upside down U for our symbol, is just where they overlap, what they share, where they touch. So let's start looking at some examples. I'm going to be using the same diagram for all problems A through G. So let's start with A. I've got segments A, B, and BC. I know that because I don't have any arrows. So if I'm looking at segment AB and segment BC, that is my intersection symbol. So where do they intersect? What do they share? Where do they touch? And that is just at point B. So the intersection point for segment AB and segment BC is B. Now on to B, I've got ray EC, which means it's starting at E and going off to infinity through point C. And then I've got ray EA, which means it's starting at E and going off through infinity through A. Now this is my union symbol, so it's saying what do these two geometries make when I put them together? And what I have here now is a line. It's going off to infinity in both directions, so that is going to be line AC. You could also call it line CA, line EC, CE, EA, or AE. Just 2 points on that line, and the order doesn't matter. Okay, let's look at C. I've got line AC, so it's going off to infinity in both directions, and line DB. And we're looking for the intersection, so where do they touch? Where do they overlap? That would just be at point E. All right, on to D. I've got segments DC and segment AB. And it's asking for the intersection. What do they share? Where do they touch? Well, they don't touch anywhere. So you could put no solution, or you could put a 0 with a slash through it to say that nowhere. There's nowhere that they touch or intersect. Okay, let's look at E. I've got ray AC, which means it starts at A and goes off to infinity through C, and ray EC, starting at E, going off to infinity, also through C. And we're looking for the intersection. Where do they touch? Where are they going to overlap? Well, that's going to be at E and everywhere off to infinity through that point. So the intersection is actually going to be ray EC. Ray EC. EC. And we cannot write that any other way because it's a ray. Ray EC. All right, F, I've got ray BA and ray BC. And we're looking for the union of those two rays. Well, that makes this angle ABC or CBA. You can name it either way. Angle ABC. So if you think back to your formal definition of an angle that we talked about last time, it was the union of two rays that share a common point called the vertex. That's exactly what we've drawn here with our two rays. All right, and then last but not least, we are now looking at the union of three different segments. I have EC, CB, and BE. What do those three segments form together? A triangle. And our 3 points of our triangle are B, E, and C, but you could also name it CEB, ECB, BEC. It's up to you, but just 3 points in any order. BEC, it forms a triangle. So again, thinking back to your formal definition we learned last time about a triangle, it's the union of 3 segments. That's what we just did here on G. Okay, and that wraps up our 1.1.1.2 examples. 1.3, we're just going to talk about some definition stuff and assumptions. So, collinear and non-collinear you should be familiar with at this point. They either lie on the same line or they don't. And then if we have a point that is in between the two, then they are also collinear. If our points are not collinear, then they could be the points of a triangle. And then our triangle inequality theorem, we'll talk about that more later on in the year, but our longest side has to be smaller than the sum of the other two shorter sides. Okay, the big, neat, important takeaway here today is our assumptions. What you can assume and what you cannot assume. You can assume straight lines and straight angles like we did earlier in our problem of straight angles. Collinearity, meaning they're on the same line. And betweenness. So like here, B, C, E, those are collinear, and I can assume that C is in between B and E from my diagram. And then relative location. So like A, C, B, I can assume that C is a little bit closer to A than it is to D. That's kind of my betweenness. What you cannot assume are right angles, congruent segments, and congruent angles, or relative size of segments. I can't say DC looks longer than BC. You can't assume these types of information if you're not given tick marks or explicitly told that in the problem. You can't assume any of this information from a diagram alone. But the stuff on the left, we can. And that's what's going to be important for you on your homework tonight, is intersection union and then what you can and cannot assume from your diagram.